Okay, good morning. I probably recognize half of the audience, and so for all of you I recognize, it's nice to see you again. Thank you for coming. For those who don't know me, I'm John Benson. I manage the emerging markets for Spectra. I also manage our software group, and I'm here today to talk about some really exciting stuff. I've been in the storage industry for 25 years, been through a lot of interesting announcements. I think this is the most interesting announcement I've been in 25 years. So today we're here to talk about this thing in the middle. We haven't told you what that thing in the middle is. That's for this afternoon. That's what keeps you around. I can't even say what it is or Molly will kill me. But that is the magic secret sauce. So the first thing I want to leave you with is this is not a tape announcement. Now, Spectra is a world-class tape company, no doubt. You came over last night, listened to our band a little bit, looked at our 50,000 cartridge T-Finity on the floor, etc. And obviously, we were very, very good at that. But what this is much, much more than that. In fact, this is a software announcement. And if you looked at our engineering organization, you would find that more than 80% of our engineers are software engineers. So we're really a software company, not a hardware company, although we have some pretty cool hardware products on the floor. And our head of hardware engineering does a nice job on those. So you heard a little bit about Nathan and Molly talk about deep storage. And you heard a little bit about storage attributes. And what I want to do is kind of pull some of those together. So we're laying the foundation this morning for what you're going to hear about this afternoon. So I want to take two deep storage examples that are near and dear to me and talk about those in a little bit of detail. So we have a fortune teller here. For those of you that can't read, she says, if you want the real lowdown, well, I'll need some of your DNA. Okay? Now, DNA technology for me is interesting and the perfect deep storage application because it's going to affect each and every one of you in this room and your children and your grandchildren. It's one of those things I think is a remarkable thing that really hasn't got enough media attention over the last few years. And in fact, this year marks the 10-year anniversary of when the human genome was completed. So if I take you back to DNA technology, really back in the 50s is when they started to understand it a little bit. By the 60s and 70s, they'd torn it apart. By the 80s, they learned to sequence it. And starting in 1990, they started the Human Genome Project. In the year 2003, they finished the first full human genome study. It took 13 years, over $1 billion. Fast forward 10 years. And now that same thing, which took 13 years, you can get done in 1 or 2 days. And instead of being $1 billion, about $5,000. So an amazing amount of reduction. Now, why is that interesting? So imagine the ability to have predictive medical things. So I have a friend. She got colon cancer in her early 40s, right? And almost died from it. Fortunately, she beat cancer, so that was awesome. But if she'd have known ahead of time that she was predispositioned to get colon cancer, she would have gone in, got screened early, and probably would have never, ever had it. Imagine being able to take pools of people, 100 women who had breast cancer, 100 women who never got it. Compare the two. Figure out why that is. We're not only getting to preventative medicine, but we're also getting to personalized medicine where each person will be able to benefit from this. So now why is that interesting to a storage guy? Well, that is a lot of data. And it's the perfect application for a deep storage type of workflow. So if you think about the average person's DNA is about 100 plus gigabytes of data, you figure hundreds or thousands of people inside one of those studies. You do the math, you end up with hundreds and hundreds of petabytes of data, and it's the kind of data that you never, ever want to get rid of. So the next one I like, video production. Even when times are hard, people like to go to the movies. And so if you go on the internet today, you'll find that The Wizard of Oz releases its 75th anniversary in 3D as of last week. Okay? Now, that was 75 years ago. There isn't anybody in this room who was born 75 years ago. And yet, we're still working on The Wizard of Oz. In fact, if you go to McDonald's today, get your coffee, you're going to find we've got the little Wizard of Oz, things in the Happy Meals. If you go on the Food Network, this week is Cupcake Week for The Wizard of Oz. And so, huge amount of opportunity there. And here's why. So if you go back, and thanks, Tom, for this. So You go to standard definition TV and you look at how much storage is capacity per hour. And it wasn't very long ago standard TV was the thing. And as you go forward, I mean, just a couple of weeks ago I bought a high definition monitor for my computer and I thought, geez, why didn't I do that sooner? You know, the experience is just so much better. Same things going on with video production. It's amazing what's happening here. And so if you go down to 4K, 8K cameras and you start getting up to these fast frame rates for sports and things like that, you end up with terabytes and terabytes and petabytes of data coming out of these video productions. And so huge opportunity for deep storage. If you take typical projects, even a small project is going to have a lot of terabytes of data. And if you get into one of these big projects where there's multiple cameras at these fast frame rates, you end up with nearly half a petabyte of data. You can say, well, geez, can everybody use that data now, et cetera? Well, when you go to capture the data, you want to get it in the highest res you can. Because in the future, you're going to want it in that format. You can always mezzanine it down to something less. But when you capture it, you want it as the highest you can. So, somebody asked me last night, what would anybody use a 50,000 cartridge Tfinity for? Well, there's an example right there. So with that, what are the key attributes to that? And why does it make it deep storage? So first of all, huge amounts of data. Petabytes and petabytes of data. On all these applications. The second thing is very long-term retention. So imagine if you had the genome data of your grandparents, of your parents, of your brothers and sisters, etc., and you could put that together and you could pass that down through the family. How long would you keep that data? I dare say you would never get rid of that data. And the second thing is it has to be very, very high integrity. You don't want to find out 20 years down the road that grandpa's DNA somehow had a bit get corrupted and flipped, right? You're not going to go back and get grandpa's DNA. It's just not going to happen. And last, to take it to the masses, to make this interesting for all of us, you have to have the right cost, okay? So I mentioned the fact this is a software technology, but we looked at the options behind the software technology in regards to what should go back there. You can have tape, you can have the Verde disk product that we showed on the floor last night, optical disk, flash even, etc. And if you look across all of those and you look at what attributes they have, it turns out that in our wheelhouse we have a lot of tape, and we're really good at tape, and tape is really good at deep storage. So tape is really the perfect fit for the back end of our software technology. And why is that? So let's start with capacity. So if you go out on the internet, you'll find out that IBM demonstrated 35 terabytes back in 2010, that was a while back, on a single tape cartridge. So that's a ton. Now that's like 30 billion bits per square inch. And by the way, that was in 2010. I'll tell you, the industry right now is looking to 100 plus. And it's doable. And why is that? Well, we have a fairly new particle technology. Now barium ferrite as a substance has been out there for a while, but not in this particular format. And so for the last few years, we've just been shipping this. This has got a lot of legs. I'm going to talk about this more in just a minute. But this is really the reason why that the tape guys are going to be able to sustain massive amounts of data for the long haul. Now, we obviously sell a lot of disk, and I've been in the disk industry a lot in my past. And if you look at what's it going to take for the next 10 years for the disk guys to keep the pace, it's going to be a lot harder. You look at the shingled memory, the hammers, etc. All of those are invention required, and all of those probably add a lot of cost to the product. And so if you look at tape and its ability right now, it's really, at least for the foreseeable future, going to be the perfect media for deep storage kinds of applications. I mean, other things, it's stored in 3 dimensions. If you look at a tape cartridge, tape is wrapped in 3 dimensions, where this cartridge is optical or only in 2 dimensions. And in fact, if you take one of those tape cartridges apart, you'll find the real trick the tape guys have isn't they're really good at recording. It's the fact that they have a ton of square inches to write on. So typical big tape cartridge is going to have over 17,000 square inches of areal density. And if you take and do the math on, I don't care how many platters you put on a disk, you're going to find you're going to end up with less than 100 square inches. And so that's really the difference there. In regards to long-term data retention, I need to talk a little bit geeky here about barium ferrite particles. If you want to know more detail, Fuji's got a great website out there. You can go out there and get the details on that. But the first thing is it's got at least 30-year shelf life. And when you start to get shelf lives of 30 years, it's sort of hard to predict what the real long one is. But if you go and you look at their website, you'll find that out to 30 years, it's perfect flat line. There's no degradation at all on it. And the reason for that is really the particles themselves. They're very, very stable. And if you look at them, I say thermally, chemically, and dimensionally, what does that mean? Well, thermally is how you keep the bits from flipping. When the bits are immune to being, as the temperature changes, typically what happens with the magnetic media is the bits flip. And if you have a very stable particle, you don't have that. Chemically, that's obvious in the fact that if it starts to corrode over time, etc., that's going to give you a bad problem. And then lastly, dimensionally, you don't want your data to grow or shrink when you're looking at certain track sizes. And so it's really the perfect media for that. Key things, signal-to-noise ratio, another techie term, but it's really got high signal-to-noise ratio. And then for a 30-year kind of particle, it's really immune to corrosion. And if you look at what we put on other medias, such as disc, etc., not so immune to corrosion. So really the perfect piece. Obviously, tape cartridges don't require any power. That's a big plus. And in regards to electromechanical damage, they're a lot more resilient than any other media that's out there on the market today. Now, let's talk about reliability a little bit. So I talked about the fact you got your DNA, you don't want that error to be lost. So again, a techie term, uncorrectable bit error rate. What that basically means is I wrote something and I made a mistake and I can't fix it. So we put a lot of error correction in products, but in this case, you actually made a mistake. And so if you look at tape, 10 to the minus 19th versus disk, 10 to the minus 16th. The 10 to the minus 16th for disk is a very aggressive number for disk, by the way. And the 10 to the minus 19th is a very conservative number for tape. In fact, it's much better than that. That's just what's published out on the web. But take my word for it, it's even better than that. So what does that translate to? That translates to, if you just do the math, about 11,000 petabytes before you do a write on tape versus 11 petabytes on disk. You say, well, still 11 petabytes, that's a lot of information before you have a mistake. But if you took 100 devices, which isn't that unusual in a customer account, you set them all to go, and you did the math, what you'd find is it'd take you 15 years to hit that on tape, take you about a week on disk. So again, the perfect kind of media for what we're talking about. And then last, cost. Everybody knows that tape is a lot less expensive than disk, but the key to this really is as the data sets get bigger and bigger and bigger, tape becomes more and more and more interesting and becomes more and more cost effective. So, why is it that we have this other piece in the middle? What's the secret sauce of this afternoon? Well, here's the key thing to these new deep storage attributes. So first of all, it's got to be really easy. So go sit down with one of these genome scientists and ask him what kind of storage he wants, because I've done that. And he'll tell you, I don't want a sysadmin person between me and my storage. I just want to be able to take my data, I've got my genome stuff, I want to put it out there, and I want to leave it out there. And when I want it back, I want it simply just go get it back and bring it back to me. And I don't want anything in between. So this is not like doing a backup where you have a sysadmin coming on the weekends taking care of all your work for you. These guys directly want access. Same thing with the video guys. Same thing with the scientific HPC guys. They just want access to their data immediately, and they want it easy. And the second thing is they need it to be over a simple, easy interface. They want to be able to do the things that Molly talked about, to be able to do searches, to be able to not have to remember everything, to just be able to go out and grab it. So these are key things that really define the deep storage. The next thing, when I say a modern interface, so today, kids coming out of school, they all think like this. None of them, we all think still about NAS and CIFS and all of that. Today, the kids coming out of school, everything is standard. 10 gig Ethernet is just obvious, right? If you're a high-performance computing guy, InfiniBand's obvious. But if you go out into these web protocols are becoming a pretty big standard out there. Not traditional, by the way, in some of the storage we've been in the tape industry, but something that's got huge promise. And we're going to show you something very interesting this afternoon in regards to one of the client components that we plugged in to this technology. And then the last couple of things that Molly talked about is because it lasts forever, I want it to transparently, without having me having to go out and figure it out, just move from technology to technology to technology. And I told you that tape lasts for 30 years, but nobody really wants a tape drive from today 30 years from now, so I don't care if it's on LTO6, LTO7, whatever else you're going to put it on back there. I want it to be able to transparently move and to do that easily. And then the last thing is, I want it to be storage agnostic. And what that means is, I don't really care what's back there. I'm a scientist with my data, or I'm a video guy with my data. I don't care what it's stored on. I just know I want it forever, and I don't want to know what's in the back end. And so as technology changes, make sure that's all agnostic to me.